Hi, this is Justin Pineda, and for today we'll be talking about two features in Burp Suite called Decoder and Sequencer. Alright, so for the discussion points here, so we'll be defining what Decoder is and Sequencer based from Portswigger. And of course, we go to the application of this. So when do we use the decoder and sequencer? Right. So for decoder, so Burp Decoder enables you to transform your data using common encoding and decoding formats. So you can manually decode your data and automatically identify and decode recognizable encoding formats, such as URL coding, and transform raw data into various encoded and hash formats. So usually this would be very helpful when you analyze requests and responses from the server and see if there are patterns, um, data patterns that you see wherein um, it is encoded. So, like if it's using binary, octal, hexadecimal, or base 64. So, it can easily provide you with a decoded value and see if it's going to be helpful for your um, testing. And usually, we provide recommendations not to use encoding for confidential, corporate, or personal information um, being sent or transferred from one server to another. Right. The second is Burp Sequencer. So the Burp Sequencer enables you to analyze the quality of randomness in a sample of tokens. And so you can use sequencer to test any tokens that are intended to be unpredictable, like your session tokens, CSRF, and password reset tokens. So what it does is it takes samples and analyze them and provides you with a result and tells you whether the quality of the randomness is good, excellent, or poor, and will provide you with um, details about it. So again, the goal is to provide guidance to the developers and see how secure these session tokens are. Okay, so one very good example of uh, a, a very good example of a bad implementation would be the use of basic authentication. And up until now, there are still applications that use this, and based on security policies and security practices, this should not be allowed anymore. So when an application is using basic authentication and it undergoes security testing or audit, the recommendation will be it should be pulled out of production and change the authentication process, because the basic authentication uses encoding in base 64, so it's not encrypted. Okay. So Apache uses HT access, IIS uses local accounts. It has no account lockout. It has no maximum number of login attempts. Okay. It's, stores in plain text. It can be replayed, impersonate the website, and there's no logout. So all the red flags are there. So the one of the example screenshot here, it will look like this, wherein there's a pop-up screen asking you for a username and password. No? So let's try to um, simulate um, this with a virtual machine that we have. So the virtual machine is here. So I have set up Burp Suite already. I will not update. So we have Burp Suite. I set the port to port 81, and I have here um, a sample vulnerable web application called WebGoat. So uh, so this is it. This is the login page of WebGoat. So 127.0.0.1:8080. So it's running on port 8080, and then WebGoat and attack. So I so it's already up. This is the and then let's turn on the proxy intercept on so we can see the request. So press enter. So you will see here that there is a request. Okay, and then let's just forward this. Okay, and then it is now prompting us to type a username and password. Okay, so this is an example of a basic authentication. So okay, so it sends the um, request. No? So one of the indicators that the application is using basic would be here. Right? It says authorization basic, and then it will show you the encoded value here. Okay, so when you look at this, it seems that it's base 64 because base 64 uses what 64 characters. So specifically the letters in the alphabet A to Z, small letters, A to Z, big letters, 0 to 9, and plus and equal symbols. So if you see those, most probably it is a, base 64. So we go back here, you see that we're able to log in. Now we go back to the target, we see the input here and see the request. So we can see that again it's using basic authentication here. Okay, so we can now highlight the value that we think is decoded and then we send it to the decoder. So we send it here. This is complete. No, this is the one, the entire thing sent to the decoder. This one. All right. And then you can now choose on decode as. So you can plain URL, HTML, base 64, ASCII, hex, octal, binary, gzip. So we choose base 64, and here you will see that you can see the username used and the password, which is guess and guessed. So that's why this is very bad. That's why we're not recommending the use of basic. And if we see any basic authentication, we have to flag it out. Right. So imagine here for all of the requests, the credentials are pasted here. Again, yeah, see authorization, authorization, and so on. Okay, so that's one application of the Burp Decoder. All right. The other is session analysis. So for this one, we'll be using the sequencer. Um, Now it's used for session token gathering. Okay, manually customized scripts using Burp Suite. Okay, so session token can be passed via URL parameter using HTTP GET. hidden form or cookie based session. So we can check for the session token predictability using Burp Sequencer. So let's go ahead and provide an example. So for this one, let's use another. Um, I'll turn the intercept off first and go to another vulnerable web app called DVWA. So let's see. All right, let's see. Let's log in. I think this one. All right, so we can check admin. Okay, log in here. So this is another vulnerable application called DVWA or dumb vulnerable web application. So here it has different security levels for our testing. So you have low security level, medium, high, and impossible. So low means that the application is completely vulnerable and no security measures at all. And then medium, more security, high, more and more security, and then impossible. So it says that the level should be secured against all vulnerabilities. Okay. Now we wanted to check what what the session IDs or session tokens look like if we're using a low security, and then later on compare it with impossible. Uh, So and apply it in the sequencer. So we submit low. Now we go to the weak session IDs here. All right. So the test here is that the page will set a new cookie called DVWA session each time the button is clicked. So if you click generate, it will generate a new cookie. All right. So let's turn the intercept on again and click generate. Okay. So this is it. So it created a cookie. So what we do is that we send this request to the sequencer. So just click right click on the request and click on send to sequencer. This one. This is it. So there's a post request. Okay. And then going back to the definition, it will collect sample tokens. So we can start live capture and then it will show you that there are requests here. Okay. So we can stop at some point, probably after 1,000 requests. Okay. So we can have a lot of samples. We can say stop. Yes. And then we can click analyze now to see the quality of session, the tokens here. So it will tell you that the overall quality of randomness within the sample is estimated to be extremely poor. At a significance level of 1%, the amount of effective entropy is estimated to be 0 bits. So there is no randomness. So it will tell you the summary here. Okay. So it's not good. And then you have to provide an example, prove that it's really not good. So you can copy the tokens and then open Notepad and then show the results. So if you would see, it's really not random because it's just incrementing by one. Okay, that's why it's vulnerable. So there is no randomness whatsoever here. So you can predict the next session token. Right? Okay. Now let's change, no? So let's remove this and then turn this on, and then let's go back to the security level and change this to impossible. So it means eh, that in this level it is secured against all vulnerabilities. So let's see what does a session ID in an impossible level look like. Okay, so it's already impossible. So let's go to the weak session IDs. And again, same process. Turn on the intercept, click generate, and then here it is. Right click again, go to send to sequencer. So this is the second one. And then start live capture. So it will again um, um, capture sample tokens. Okay, so let's stop. Yes. All right, and then you can click analyze now. So here, I, let's read the summary. Overall result: the overall quality of randomness within the sample is estimated to be excellent. At a significance level of 1%, the amount of effective entropy is estimated to be 149 bits, which is good. What does it mean now? So again, you can copy the tokens and see. Okay, so this is what an excellent result will look like. So very long, diverse, random, and, and it's hard to predict. Okay, and and then usually this is what we show the developers. This is how your session tokens look like. This is what we want your session tokens to look like. Right, so it will give them an idea that okay, the entropy is very important. Okay. There. All right, so there no, so these are some of the applications of burp decoder and burp sequencer. So for this session we're able to use the decoder to um, check the values and uh, decode them and see if we can make use of them. So for basic authentication, it's really applicable, right? And then for the sequencer, we check the quality of session tokens and compared a, an extremely poor um, session token versus an excellent session token. All right. So thank you for listening and watching, and we'll see each other in the next video.